Imagine standing at the edge of the world, staring out at a mile-wide strait of swirling, treacherous water. Fog so thick you can taste it rolls in, swallowing the coastline. Fierce Pacific winds howl, and beneath the surface, a current rages with the force of a river, capable of tearing ships apart. Now, imagine being told to build a bridge here. Not just any bridge, but the longest, tallest suspension bridge ever conceived. In 1933, this wasn't just a challenge, it was deemed an act of madness. The Golden Gate Strait was where engineering dreams went to die. But one man, armed with a radical vision, would defy the impossible. This is the story of the master plan that conquered the gate. Welcome to the master plan, where we uncover the extraordinary tales of engineering and ingenuity that shaped our world. Today, we're diving deep, literally, into the frigid waters of San Francisco Bay to expose the secret that holds up one of the most iconic structures on Earth, the Golden Gate Bridge. It's a story of courage, concrete, and the colossal gamble that had to be won before a single cable could ever be spun. To understand the sheer audacity of the project, we have to go back to the early 20th century. San Francisco was a booming metropolis, but it was geographically isolated, a city on a peninsula. To the north lay the vast, undeveloped lands of Marin County, separated by that formidable strait. Ferries were the only link, a slow and inadequate solution for a city with grand ambitions. The dream of a bridge was decades old, but experts dismissed it as pure fantasy. They cited the powerful tides, the constant corrosive fog, the deep water, and the ever-present threat of a catastrophic earthquake along the San Andreas Fault, just 7 miles offshore. Over 20 times, bridge proposals were submitted and shot down. It was, they said, impossible. Enter Joseph Strauss, a brilliant but notoriously stubborn engineer. Strauss was known for his smaller, functional bridges, but he had a colossal ego and an even bigger dream: to build the Golden Gate. He submitted his initial design in 1921. It was, frankly, ugly and clunky, but Strauss was persistent. More importantly, he was a master promoter. He spent a decade battling political opposition, lawsuits, and a skeptical public. By the time the project finally got the green light in the depths of the Great Depression, Strauss had assembled a team of visionary engineers, including Charles Ellis and Leon Moisseiff, who would refine the design into the elegant Art Deco masterpiece we know today. But the beautiful towers and sweeping cables were the easy part. The real nightmare lay beneath the waves. The North Tower could be built on a solid rock shelf near the Marin shore. The South Tower, however, had to be planted more than 1,100 feet out into the open strait, in the most dangerous part of the channel. Here, the seafloor was 100 feet down, and the currents ripped through at over 7 knots. Divers attempting to survey the site were thrown around like dolls. No one in history had ever attempted to build a bridge foundation of this magnitude in such hostile open ocean conditions. This was the problem that could sink the entire project before it even began. The first attempt was a disaster. The plan was to build a temporary access trestle, a wooden pier stretching out to the tower site. It took 5 months of grueling work to build it. Then, in the winter of 1933, massive storm surge crashed into the strait. The ocean obliterated a huge section of the trestle, washing away months of work and millions of dollars in an instant. A second attempt to build an even stronger trestle was also heavily damaged. The engineers were facing a terrifying reality. The ocean itself was rejecting their bridge. Morale plummeted. The press called it Strauss's folly. The project was on the brink of failure. This is where the master plan truly begins. The team knew they couldn't fight the ocean head-on. They had to outsmart it. They needed a fortress, a massive wall that could protect the worksite from the full fury of the Pacific. The idea was to build a gigantic, oval-shaped concrete fender, like a dam in the middle of the strait. This fender would be a hollow structure, the size of a football field, and as tall as an 11-story building. It would create a calm pool of water inside, a lagoon where workers could safely excavate the seafloor down to bedrock and pour the foundation. It was an unprecedented, high-risk maneuver. To build this fender, they first had to level the ocean floor. Specialized blasting crews, working from boats tossed about by the waves, used long pipes to place explosive charges on the uneven seabed. They detonated thousands of pounds of dynamite in a series of controlled underwater blasts, a process that took over a year. With the seabed prepared, the construction of the fender began. They built a floating framework of steel and towed it into position. Then came the endless river of concrete. Barge after barge arrived, pumping concrete down through tubes, layer by layer, building the walls of the fender up from the seafloor. As the fender rose, a strange structure appeared in the middle of the strait, a man-made island of concrete. Once it breached the surface and its walls were complete, the magic happened. They pumped the 18 million gallons of water out from inside. For the first time, workers could descend into the enclosure and stand on the seabed, 100 feet below the waves, in a dry, protected environment. The roar of the ocean was silenced, replaced by the sounds of construction. It was an engineering miracle. With the site secured, they excavated another 20 feet down to solid bedrock and began pouring the South Tower's foundation, a solid block of concrete weighing over 130,000 tons. It was the anchor that would make the impossible possible. From there, the two towers began their majestic ascent into the sky, reaching a staggering 746 feet. Then came the mesmerizing process of cable spinning, where individual steel wires were shuttled back and forth across the strait, bundled together to form the two main cables, each one 3 feet in diameter and containing over 27000 individual wires. These cables hold the weight of the roadway, the cars, and the bridge's own immense structure, transferring that colossal load down through the towers and into those unshakable foundations buried deep beneath the waves. On May 27, 1937, the Golden Gate Bridge opened to the world. What was once dismissed as a fantasy now stood as a testament to human will. It was completed ahead of schedule and under budget, a monumental achievement during the nation's darkest economic hour. But the true hero of this story isn't the iconic orange steel or the soaring towers you see. It's the unseen, underwater fortress that no one ever gets to witness, the fender and foundation of the South Tower. It is the masterstroke of a plan that stared into the abyss and refused to back down. It represents the quiet, brutal, and brilliant work that makes grand visions a reality. The Golden Gate Bridge isn't just a bridge. It's a monument to the idea that with enough courage and ingenuity, there is no such thing as impossible. Thanks for joining us on the Master Plan. If you enjoyed this deep dive into one of history's greatest engineering feats, make sure to hit that like button and subscribe to our channel. We have many more stories of incredible ingenuity to share. See you next time.